Hello again. Now, we need to talk a little bit about security before we finish up the course. This is based upon a small part of Chapter 12 in the Engineering Software as a Service textbook. So I'll point you to that reading in Learn. So the authors talk about that security experts boil security down. Now, security is a gigantic field, but boil it down to three key principles that we need to think and know about. The first principle is the principle of least privilege. This is sort of like if you've seen in the movies on a need-to-know basis for, the spies or people in the military and stuff. The idea here is that we won't give you any more access or information than you need to actually get your job done. And this is in the context, yes, of computer security. So it's the users who are using our system, but also internally as far as the processes, the objects, and all sorts of stuff. They shouldn't be able to do things unless they've been given access. All right, so we shouldn't just have extra information available to get jobs done. We should only be using the information necessary. I think the best example of this in sort of our day-to-day life is with your own personal computer. So you may be aware that there is some users on your computer who are set up as administrators. They have more power. And then there are like regular users. Then again, maybe you've never been aware of this. But general security practice is that in day-to-day usage, you and anyone else who uses your computer should only be using a regular user account. Regular user accounts, for example, can't install software. They can't modify the operating system. They can't change anything except their own data. So a regular user can't go read another user's data, can't modify their stuff. So let's say you're surfing the web, and for whatever reason, maybe you haven't updated your system recently or not, but you visit a website and you get infected with malware. So that malware comes in, but it only comes in with the access privileges of your current user account. So if you're only a mere user, you won't affect other people's data on the computer. You won't affect the operating system. You will limit the repercussions of this the security problem that you have. On the other hand, if you are logged in as the administrator, if your user account has administrator access, when you have that security violation, that process now can go and do everything to the computer because you're logged in as administrator. So it can go and encrypt everything. It can just, so to limit the impact, you want to you don't need for everyday computing to be logged in as administrator. So you shouldn't be logged in as the administrator for everyday computing. We can come back to that when we get to principle 3. Principle 2, principle of fail-safe defaults. Unless given explicit access, deny. So the idea here is basically like you should have locks on your doors and you should lock them, okay, and have keys. You should not have easy access to stuff. You should actually have things locked up, okay? So think about it's like the front door to your house or the door to your apartment. Do you leave it unlocked? Well, you shouldn't, by the way. But the idea would be, no. You don't want to just simply trust that people will not walk into your house or walk into your apartment. Again, the classic problem of college or university life in dormitories or residences is someone might come home and they are not being too careful. And if you're door to your room is unlocked, they can end up in your room. Not good. You should have it locked so that you have a fail-safe, sort of a safe default, which is you are denied unless you have a key. Okay? Use the locks. Lock things up. So this is a basic principle of security. Then the last one, psychological acceptability. Look, if you make things so tough that people decide it's not worth it, you lose the advantage of the security that you've put in place. So back again here with the example of the admin account, I mean, it can be a little frustrating at times, at least in the olden versions of Windows, to get anything done. Almost all the software was written assuming you were the administrator. I think things are pretty good now in Windows 10. You can actually use a regular user account and not really need to update or change your software, and things seem pretty sensible there. But another example here is like, I remember I had a friend and we worked at a company, and the company, every, couple months required you to change your password. And it made sure that you didn't do something like change it to something new and then change it immediately back. It kept a history of, let's say, your last 5 passwords to make sure that you weren't repeating your passwords. So my friend, being a computer programmer, just simply wrote code that would, it's time to change my password, and he'd run this code, and it would take his current password, change it by modifying it 6 times until it cycled back and then back to the original password and set it to that. So he could basically defeat their security mechanism because it was such a onerous thing to keep changing your password. If you've got a good password, there's not a great reason to have to keep changing it. Anyways, so the big thing is, again, you make it hard, you make it so that people are frustrated with the security, they will work to evade it or not follow it. So it has to be psychologically acceptable to people. Anyway, 3 principles of security. Now let's talk about some specific things about web apps. All right, so I won't get into too many details here, but there's some additional, so these are sort of more specific recommendations. Basically, use encryption. You need to use it to and from your app. In the early days of the web, nothing was encrypted except for banking and shopping cart stuff. Thankfully, people have learned that that was a mistake, and that basically all our traffic over the internet should be encrypted. And there's a little bit of a computational overhead, but absolutely you should be always be working with encryption turned on for your apps. All the data that you go back and forth should be protected, and people shouldn't have to worry about other people listening into what they're sending to the website or receiving from the website. All right. Other thing, though, a big thing is that you should really be careful that all private data in your database is encrypted. And so this is getting at, passwords. Yes, passwords need to be encrypted. It can't be in plain or clear text. But also, there's all sorts of personally identifiable information that if your database was to be compromised, and someone was to somehow be able to get access to it, you wouldn't want them to see what was actually in there. You wouldn't want them to download millions of customers' personally identifiable information. That should stay private between you and the customer. So that sort of information should actually really be encrypted inside the database as well. And think about other stuff. It's not just about your data. It's that data, and it's not just about hackers coming in, but even developers and employees, people who have access to that data, but they shouldn't actually be able to see it. Okay. And so should they be able to find like the phone number of any person who's a customer? Well, only if that's in their job. They're a customer service rep, they pull up the account, yep, here's your phone number, blah, blah, blah. But if you're just a developer, should you have access to someone's phone number? Probably not, actually. Should anyone at any time have access to phone numbers? No, probably not. Probably only that customer support rep who has, who's going through a series of prompts and authentications to actually access the customer's account, they should be able to see it. I know that might sound draconian, and I bet most companies haven't bothered to encrypt half that information. But then again, those same companies end up in problems. We're learning more and more stuff needs to actually be encrypted when we store it, and we need to have those basic security principles where you need this only on a need-to-know basis. For example, all your email that you have in Gmail, I sure hope it's actually encrypted by Google so that regular employees can't read it. And I'm pretty certain it is, okay? The application can read it and can use it, but regular employees shouldn't be able to have access to it. All right. And I certainly don't want, if someone breaks into Gmail on the back end, for them to read my email and distribute it to the world either. Anyways, another thing that you should always have encrypted is the cookie that you store. You shouldn't store an unencrypted cookie on the person's browser. They can go in and they can look at those cookies. It needs to be encrypted. The good thing is that if you're using Rails, by default, it does this for you. Okay, so that's not a concern. What else do we have besides using encryption? There's this web issue known as Crosssite request forgery, the CSRF. All right, what's the actual problem? Well, the idea, this is an example from the book. So let's say you have a banking website, and then let's say you have over here some sort of chat or community group site or who knows what. All right, so you as a user, you go, and the first thing that you do is you go log in at the bank site. So that goes and makes you a nice, sets a cookie. You're authenticated, your browser is like all happy, you're at the bank site, and you're logged in. And you don't bother to log yourself out. You don't bother to cause the site to remove your cookie. You just left the site. All right. So 2, you go to your chat site, whatever it is, I don't know, some sort of site or forums or something. You go over there and someone posts in there. They're able to include there, and maybe it's actually a rogue. Maybe it's the person who wrote the site and they're like evil. And they have in there an image tag, and for their image tag, the source does a HTTP, blah, 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 to whatever your banking website is. And let's say your banking website was written very poorly, such that a GET request could go. So the idea is you're going to have like this image tag. So when you load this page here, your browser says, oh, I have to go fetch all the images on the page. So it goes and says, oh, I need to fetch this image. This image is located at bank.com, this banking site, /transfer/902109/100. So this is like a banking account number. This is how much money to extract out of your account and put into this account number. So the attacker has this bank account. We're going to transfer from your account to their account. All we're doing is issuing a GET request. Oh, Well, don't worry, it's not going to work, right? No, you're logged in here. You know, you're logged in here, you're authenticated. The bank comes says, oh yeah, hey, good for you. Thanks, I'll process that request for you and transfer the money to that bank account. That's cross-site request forgery. It's a request that really should only be happening on this site, but it's coming from someone else's site, and it's taking advantage of the fact that you're currently logged in here. One other good reason to get in the habit of, when you're doing secure things, to log out to avoid cross-site request forgery attempts, at least. Now, what do you need to do to protect yourself and write websites? What do you need if you're the banking website and you want to protect yourself from this sort of attack? Well, first of all, don't go around not having a non-restful design. So the first thing to do is you should use a RESTful design. That will help you quite a bit. So gets should only be for reading of data, okay? And posts, which include the good old patch and delete, are for changing data. And you can see how much more trouble it would have been for that person to try to do cross-site request forgery with a post. They would have to actually get you to submit something and have it be submitted to the other site. And again, maybe it's not that hard actually. But that's a good first step. Be sure to use a RESTful design. The next thing is, use a web framework like Rails. Because Rails in particular has this whole thing, you might have seen it, the CSRF meta tags in the default application layout. I hope you haven't removed it. So you want to leave that in there. Then always be sure to use the framework's methodology for handling forms. And then for us, that's form with. So if you ever go and view the source on the HTML page for a form that's been generated with form with, you'll see that it has this hidden field with this long random string in there. That is the token that's generated so that the Rails will only accept a post that has that proper token based upon these tags and so forth, so that the requests need to come from within the site, basically. These are tokens that are being generated by the site, and the site will refuse any post that doesn't have that token, okay? And it's not just a single token. They're generated per page and data and all sorts of stuff. That's a complex thing. But Rails is designed to, if you follow the framework, to help protect you against cross-site request forgery attempts. Don't try to hack your own solution to it. Always use an existing, well-tested web framework. Okay. That's another reason to stay up to date, by the way, with all of the web frameworks. As they've been updated through the years, they add additional security features by default for you to protect you. Now, one of the biggest things to worry about is SQL injection. What is SQL injection? Well, I'm going to use the example from the book. But the big thing here, I'm just going to, we'll just go ahead. I'll use the example. So this is an example. So you've got somewhere in your Rails app some code in like a controller. Movies is going to be set to movies. So you got some model, where, and you have a name. and you decide, so this is do not do this. So this is the bad example. This is an example of SQL injection. And you decide, oh yeah. What I'll do is I'll collect from the user on some field named title, the title that they'd like to search for. Okay, and I'll interpolate and put that into my string. All right, so if you remember, you've got the pound key or hash mark, and then the curly braces, and that will then allow you to go ahead and string interpolate, okay? So you're taking directly what the user types in here and putting it in to your active record call. Oh, this doesn't feel good, does it? So if they type in, you know, Star Wars, no problem. You're going to find the movie name with a name equal to Star Wars. Great. If on the other hand, they happen to be a hacker, so say the user enters, they entered this as their string, a single quote mark, right parentheses, semicolon, drop, table, double quote, movies, double quote, semicolon, dash, dash. So this is what they type in for the title field on the form, and they hit submit. All right, well, now when this goes and gets interpolated in there, and when active record goes to generate the SQL query, we're going to get a SQL query generated, which is equal to select movies from movies where title is equal to single quote, single quote. So this is the start of what the user typed in. Then they continued on with their parentheses, drop table, quote, movies, end quote, semicolon, dash, dash. So what they've done is they've been able to take the query you wanted to have generated and extend it and add on another SQL query to it, which they have guessed. You know, they could keep trying at this until they succeed. Yeah, you've got a table probably named movies. I'm going to drop your table. It runs with the permission of the application, which has the ability to change things in the database, and the table gets dropped, and your web app is destroyed. You know, this could be, and it's not just destroying your app, they could be using this also for various ways to extract data from the database, okay? We don't want SQL injection. SQL injection, bad. How do we avoid it? We always need to use prepared statements, okay? So always use prepared statements. So for example, you've got your movies.where, and you do name equals question mark, then comma, the params and title. Okay, so now this is special. This is not normal Ruby. What this is says, okay, what we're going to do here is we're going to take this value and then we're going to sanitize it. So Rails or active record will sanitize this string before using it in the SQL query. So it will transform it, and it will not allow SQL injection to actually happen. It will protect you. So always use prepared statements so that the mechanism can actually be used and not end up with SQL injection. Thus, again, pointing to we should use a proper web framework that has these mechanisms in place for us. And we should not defeat them. So, unfortunately, it's very easy to defeat them, especially if you aren't aware of the problem. All right. Another thing mentioned is the issue of cross-site scripting. So similar to this cross-site request forgery. So this is XXSX. The big thing here is people trying to use JavaScript code and all sorts of stuff and take advantage of you. What you need to do is to be sure to use, in Rails, use herb. And again, don't defeat its protections. It's turned on by default to protect you from users supplying you malicious data and then you displaying it on the page. Okay, so the idea is, let's say you write a blogging app and you allow users to type in input and you store it and you later display it on the page for other people to see. If that user sends you in HTML and JavaScript and stuff and then you just put it back out on the web page, the other person who's viewing the web page then can be subject to attack. So this herb is certain that data that you say, oh, herb, please display this, it sanitizes it and makes sure that it can't be interpreted as HTML and JavaScript on the page. There's also the problem of denial of service attacks. So this can be a result of lots of requests, but the better way for people to do it is to figure out what might be an expensive operation for you and then request that operation repeatedly. So in particular, if you have long-running tasks, you should certainly be protecting them, but maybe you let anyone do them, then they should be put into a queuing framework so that the main web app is not subject and it's just the queue that fills up and slows down rather than the main web app. We haven't talked about how to make job queues and stuff. Yeah, it's a problem, but one to be aware of. All right, so that's our whirlwind tour of security. Let's have a conclusion with it and summarize it again for everyone. Our conclusions, all right. Use a framework. This is a big one. And work within its setup. Don't defeat it. So you need to know, oh, how do I use this web framework properly to avoid SQL injection? How do I use this framework to make sure that I'm using its protection against cross-site request forgery, and so forth and so on, okay? It's a useful thing overall to be RESTful, but it can also help avoid running into problems with people accidentally or making it easier for them to do destructive actions. The book then also mentions to, make use of the various before filters. So this is like when we're working on the controller and we have, before the, we want these actions to happen before, if we want certain methods to be called before any methods other methods are called. We use these before filters. And so this allows us to be sure to protect sensitive controller methods. So this is your means of doing that. It's the best way is to use those before filters. Yes, if in doubt, encrypt. Certainly, you can't, encrypting everything in the database becomes very problematic. How do you search for stuff or use keys and things if you've encrypted them? So you can't encrypt everything. But sensitive data should certainly be encrypted. The textbook is like, don't even think about starting to try to save things like credit card numbers. You should actually just use another third-party provider, you know, like PayPal or whatever, to process credit cards for you. You don't want to even get into the world of that trouble. One thing that this needs to be mentioned that goes along with this, though, is no passwords in the repository. Now, you're like, oh, but it's all nice and private. I'm hiding it from the world. Again, what if you have a security breach? Again, every developer on your team has access to it. All it takes is one developer to have a bad password, and then the attacker is able to see your repository, and then they're actually able to get your passwords that you've hidden in there. Likewise, if it's in the repository, it means it's on the deployed site. If you have any security issues or leaks, that password is visible in the code sitting on the site. Not good. Now, some people have set up things that, for example, in the apps they built this term, that the administrator account comes with a default password, which then when you log in, you can change. That's fine, because you're going to launch the site. If someone was to get in there and change it, you would know because the password's no longer the same. And then two, though, you don't have any sensitive data in there yet. So that's not a bad thing, just so long as you can actually change the password. If you can't change the password, you're stuck with what's stuck in the seeds file. And that's that's not good at all. So there are times, though, that you need to give your application sort of API codes and other sorts of things so that they can talk to third-party providers. And what do you do when you need to do that? So basically for, you know, APIs, etc., places where you need to have these secrets, there is a mechanism in Rails called credentials. And you can read about that. This enables you to have a master key. You do not keep the master key in the repository. The master key has to be kept in a secret, secure location. And then you put your master key into an environment variable in Heroku. So it's never physically written down in a file. And then that master key is used to, at runtime, unlock the credentials when you need to read them and use them, for example, to access something on Amazon via the web API. You would not want your Amazon Web Services codes available to other people. The next thing you know, they have launched thousands of websites to be Bitcoin mining and stuff. People have had situations where they let their APIs are not protected properly, and the next thing they know, they've got a bill from Amazon for $50,000. You don't want that to happen. You got to put things properly encrypted with the credentials and use this master key. We're not going to cover that. You just need to know that it exists, and when you're like, oh yeah, I have one of these things, and remember, I'm not supposed to put it in the repository. Find the mechanism that your web framework has and use it. All right, that's web security, app security in a nutshell. There's tons more to know, but this is a good start. All right.